Welcome to part 2 of the SureServo2 Torque Mode video set. In the first video, we explained how Torque Mode works and went through some of the basic parameters needed to get started. Watch that video first prior to seeing this one. Now that we have our basic parameters set, let's do some basic motion with our system to make sure everything is working in the real world. As a reminder, we have 4 torque set points, including 0 torque, and 4 speed limits, the analog input, and our 3 presets. DI1 is our servo enable, DI2 is our direction change input, DI5 is an alarm reset, DI6, 7, and 8 are our forward and reverse over travels, and our motor override stop. DI3 and 4 form a binary word to select which of our torque selections we'd like to use. If both are off, we select 0 torque. If only DI3 is on, we select torque 1, which for us is set to 65% of motor rated torque. If only DI4 is on, torque 2, which is the default of 100%, and if both are on, torque 3, which is also the default of 100%. To select our 4 speed limits, we are using DI9 and DI10, and they work exactly the same way as the torque inputs. Nothing on selects the VREF analog input terminal, which is scaled based on the maximum speed set in P1.040. If we only have DI9 on, we select speed 1, which is set to 10 RPM. If we only turn on DI10, the motor speed will run at 20 RPM. And if we turn them both on, it will run at 30 RPM. We also have our maximum speed limit in P1.055 set to 100 RPM for safety. Never forget that. To help with seeing the timing on all this, let's do a little sports-style picture-in-picture and show the motor and actuator, the drive face, and the software all at the same time. I'm already online with the drive after setting all the parameters in the last video, so I will start by turning on DI6, 7, and 8 to clear the overtravel and override stop alarms. We see the alarms clear in the software and on the drive face. I can now enable the servo by turning DI1 on, and we see the servo on message in the software. Let's select something other than 0 torque by turning on DI3 to get the minimum torque for motion. And nothing really happens. We forgot to select a speed. I have the VREF terminal set to basically 0. If we go to the left side of the servo software and select analog I/O, we can see that the input is set very low, which corresponds to almost 0 speed. This is a lesson for us to be careful during testing of any motion system. If we had had full voltage on the terminal and hadn't fixed our maximum speed setting, we might have sent the system running off at 3,000 plus rotations a minute. Imagine this was a huge drive and actuator, and you can picture why carefully planning all possible speed settings is so vitally important. As always, ensure you have an e-stop wired up to your system as well. Let's turn off DI1 and DI3 to disable the servo, and now DI9 to enable our slowest speed limit. And DI1 to re-enable the servo. DI3 again, and still nothing really happened. Maybe we aren't going into the correct direction. Maybe we're driving down into the bottom of the motion base rather than up. Let's try DI2 to reverse our direction. And there we go. Still moving, but at a much more manageable speed and in the correct direction. If we turn DI3 off to stop the torque output, gravity pulls our system back to the bottom. Now let's turn DI9 off and DI10 on for a medium speed. We can flip DI3 back on and see our speed increase. Let's turn DI9 back on while DI10 is still on to select our third and fastest speed. And there it is. When it gets to the end of travel, we turn off DI2 and it goes the other way in a controlled manner rather than being driven by gravity. Perfect. Let's let it get to the other end of travel. And turn off DI3 to stop torque output. Good. And DI2 back on to turn it around for the next run. Alright, so we've established that we can select multiple speeds and change direction. Let's see if we can increase the torque enough to see a speed decrease while in motion. We will turn on DI3 again to set the motion base moving, and now I will add a 1 kilogram weight. We see the motion base slow down as it comes into torque equilibrium at the set point of 65% of motor rated torque. And we see that on the face of the drive as well. Let's turn it around and bring it back down with DI2 again. And we will remove our 1 kilogram weight. Let's turn on DI2 to start it moving upwards again, and we add our 1 kilogram weight and see it reduce speed again as it comes to its equilibrium torque. Now let's add another 500 grams of weight And we can see that since it wants to stay at the 65% torque value, it decreases speed to compensate, and in this case has come to a standstill. Perfect. Since it is still engaged and targeting that 65% number, let's turn on DI4 while DI3 is still on, and we will jump to full motor torque. It immediately resumes moving again with the added weight as we have allowed the motor to output more torque. Perfect. As you can see from this example, setting up torque mode is relatively straightforward and opens up a ton of possibilities, features, and functionality that you cannot achieve in the velocity and position modes. If you need further technical assistance with your torque mode application, please contact our free award-winning technical support. If you liked this video, give it a like and subscribe to our YouTube channel here. If you want to see more SureServo2 videos, click here. To visit our web store for SureServo2 products, click here.